Hello friends, myself Vivek, Assistant Professor, Shell Institute of Technology, HLK. So in my last video, I have discussed how to find Fourier sine transfer of the given function, as well as I have discussed about inverse Fourier sine transfer. So in this video, I am going to discuss about Fourier cosine transfer as well as inverse Fourier cosine transfer. So first we will see the definition, then we will go for the example. So here the infinite Fourier cosine transfer f of x, where x lies between 0 and infinity, is denoted by fc of s and is defined as fc of s is equal to under square root 2 upon pi integration 0 to infinity f of x into cos sx dx, as well as inverse Fourier cosine transfer is given by f of x equal to integration 0 to infinity fc of s into cos sx into ds. So here you have to observe, in case of Fourier cosine transfer, the integration is with respect to x, and in case of inverse Fourier cosine transfer, the integration is with respect to s. So now I will take one example based on the formula. Find So now I will take one example on Fourier cosine transfer. Find Fourier cosine transform of e to the power of minus a into. So in this example, we are going to find the Fourier cosine transfer solution. Here f of x is e to the power of minus ax. So first I will the formula for Fourier cosine transfer. We know that fc of s is equal to under square root 2 upon pi integration 0 to infinity f of x into cos sx into dx. Therefore fc of s I will write as it is square root of 2 upon pi integration 0 to infinity. Here the value of f of x is e to the power of minus a into x cos sx into dx. Now to find the integration of e raised to minus into cos sx, so I will use the formula integration of e raised to x into cos bx, because it is the product of exponential and trigonometry. So we know that integration of e to the power of ax into cos dx is equal to e to the power of ax upon a square plus b square, a cos dx minus plus b sin dx. So this is the formula. So to solve this integral, I am going to use this formula. So first I will compare the given integral with the formula. So after comparing, I can see here the value of a is minus a, the value of a is here minus a, and the value of b is here yes. So b is equal to what here? Yes. So therefore fc of s is equal to e raised to ax, so it becomes e to the power of minus ax upon a square minus a whole square is nothing but again a square plus b square. B is yes here, it becomes s square. So into a cos bx, that is minus a cos s into x plus b sin dx s into sin sx. So between the limit 0 to infinity. So therefore fc of s is equal to, so here I have forgotten to write, this is here square root of 2 upon pi fc of s. Here I have forgotten to write this square root of 2 upon pi. So here I will write square root of 2 upon pi as it is, and 1 upon s square plus a square also as it is, because it is constant as we are integrating with respect to x. So now I will put here upper as well as lower limit. So here upper limit is infinity, a into infinity is infinity, e to the power of minus infinity value is 0, minus lower limit is here 0, x into a into 0 is 0, e to the power of 0 is here 1, into, I will put here x equal to 0, s into 0 is 0, cos 0 value is 1, so the remaining is here minus 8, and sin 0 value is what here? 0. So therefore fc of s is equal to square root of 2 upon pi, minus into minus it becomes plus a upon s square plus a square. So this is what the Fourier cosine transform of the function e to the power of minus e to the power of. So now we will take one more example on Fourier cosine transform. Find Fourier cosine transform of f of x is equal to x lies between 0 and 1, 2 minus x lies between 1 and 2, 0 for x greater than 2. So here you can see the function is divided in 3 different ranges. So first I will write the formula solution. So we know that Fourier cosine transform is given by square root of 2 upon pi integration 0 to infinity f of x cos sx into dx. fc of s is equal to square root of 2 upon pi. So I will write as it is here. So as per the range, I will divide this range 0 to infinity by using the properties of definite integral. So I will divide 0 to infinity as 0 to 1 f of x cos sx into dx plus 1 to 2 f of x cos sx into dx plus 2 to infinity f of x cos sx into dx. So fc of s is equal to under square root 2 upon pi integration. So between 0 and 1, f of x is given by here x. So this is what? Integration 0 to 1 x into cos sx into dx plus integration 1 to 2. In between 1 and 2, the function is defined as 2 minus x. 2 minus x into cos sx into dx plus in between 2 to infinity, the function is here 0. If I put here 0, 0 into any number, it becomes 0. So now, I will integrate this one. So to integrate this one, so I am going to use generalized Laplace formula. So I will write this formula here. uv into dx. So in the number, I will write u as it is. Integration of v is v1 minus derivative of u is u dash. Integration of v is v1 is v2 plus derivative of u dash is u double dash. This is v3 minus plus so on up to infinity. So here this is u and this is v. Here I have applied Late rule L I A T E. So A is here algebraic and T is here trigonometric. So I will take this one as sum u. Again this is what? V. So therefore fc of s is equal to, so I will write here square root of 2 upon pi as it is. I will write first term x as it is. Integration of cos sx, that is v1, is nothing but sin s into x upon s minus, in formula we are having minus sign, u dash, derivative of x is 1, integration of sin sx is minus cos sx upon s. Here already we are having 1s, it will become s square. S square. So between 0 to 1 minus, not minus, it is plus. Now I will integrate this one. I will write u as it is. Integration of cos sx is again sin s into x upon s minus derivative of 2 minus x is minus 1 into integration of sin sx upon s is minus cos sx upon s square, because here we are having 1s and s into s become s square. So between the limit here 1 to 2. So I will simplify this one. Therefore fc of s is equal to square root of 2 upon pi. So I will write x sin s into x upon s as it is, minus into minus become plus, cos sx upon s square. So between limit 0 and 1 plus 2 minus x into sin sx upon s. So minus into minus into minus, it will come again minus cos sx upon s square between 1 to 2. Therefore fc of s is equal to square root of 2 upon pi. So here I will put upper as well as lower limit. Upper limit is 1 here. So if I put upper limit as 1, x equal to 1, it becomes So remaining is here sin s upon s. 1 into s is s plus cos s upon s square. So this is upper limit minus lower limit. Lower limit is x equal to 0. 0 into any number is 0 plus cos 0 value is 1. So remaining is 1 upon s square plus second part. So upper limit is here 2. 2 minus 2 is 0. 0 into any number is 0 minus, here it becomes cos 2s upon s square minus lower limit. Lower limit is here 1. 2 minus 1 is 1. And it becomes sin s upon s. Here also I will put x equal to 1 minus. So this is what cos s upon s square. So I will simplify this one now. So therefore fc of s is equal to square root of 2 upon pi. So I simplify sin s upon s plus cos s upon s square. This is minus 1 upon s square. So plus into minus minus cos 2s upon s square. So plus into minus sin s upon s plus into minus minus into minus plus into plus, this becomes plus cos s upon s square. So therefore fc of s is equal to square root of 2 upon pi. Here sin s upon s and sin s upon s get cancelled. So cos s upon s square, here also we are having cos s upon s square, it becomes 2 times of cos s upon s square. So minus 1 upon s square, I will write as it is, minus cos 2s upon s. So this is the required result. So thank you. So in this video we have seen the definition of Fourier cosine transform, inverse Fourier cosine transform, and we have solved 2 examples on Fourier cosine transform. Thank you.